There's been another warning of severe weather today, this time for southeast Scotland. Such alerts seem to have become a regular occurrence. And after the wettest April on record, you could be forgiven for thinking rain is Britain's default forecast. But just why are we experiencing such downpours? For tonight's special report, our science editor Tom Clarke has joined the Stormwatchers, who get up close and personal with the kind of weather most of us would like to avoid.
It's been the wettest April on record, and it's done little but rain since.
From next Wednesday onwards, we are expecting another period of unsettled weather.
Grey skies, torrential downpours of rain, and a risk of some localised flooding too.
More rain sweeping across England and Wales with some torrential downpours.
But precisely where does the worst of our weather come from? And is it possible to improve our forecasts of where and when it will hit? Before last night's band of heavy rain arrived, this team of scientists was preparing to go out and meet it head on.
Chill Bolton radar will be measuring. We hope there'll be plenty of rain for it to measure.
Their aircraft is one of the world's most well-equipped storm chasers, armed with atmospheric sensors and adapted to fly through high winds and ice. And they invited us to fly with them. This flying laboratory takes scientists to the part of a storm their equipment on the ground can't reach. From up here they can give bad weather a thorough physical examination, probe it with radar, measure it with lasers, take its temperature. Hidden details that will improve forecasts back on the ground. While most of us run away from rain, the scientist leading this team heads right at it.
We're looking at the leading edge of a storm coming in, and after it's come in, we are expecting a downpour basically, and the country will get a soaking. What are we hoping to find? Well, we're hoping to find a fair bit of rain when we get out there. You never know with this work, you know. You can look at all the forecasts you want, but the weather has a mind of its own, so we're keeping our fingers crossed here.
After heading out towards Ireland, the 5-hour flight turned south into that warm front. Descending through the rain to just 1,500 feet above sea level, it took a cross-section of the storm, then flew along the frontal system before tracking back and forward in front of a ground-based weather radar in Gloucestershire. That's because this flight is trying to relate what's observed on the ground to what's happening inside the clouds. The goal to improve the accuracy of forecasts. It requires detail, and this is a plane that can see individual snowflakes.
Particles inside the clouds move very quickly, and they're constantly developing and changing. And those changes affect how much rain will fall, duration of these rain showers, and how intense each storm will be. So getting down to the very small scale allows us to build a much detailed, bigger picture.
While that's going on, more sensors are being dropped out of the back of the plane.
Okay, stand by, release.
Essentially weather balloons in reverse, these tubes descend through clouds on a parachute, sending back more measurements via satellite. It's getting a little bit bumpier now, which is not perhaps that surprising, seeing as we're flying straight through the middle of a warm front. But rather than looking anxious, these scientists seem to be quite enjoying themselves. The storm we flew through caused today's steady rain across Britain, but it was a sustained downpour that no forecaster could have predicted that nearly carried the village of Boscastle in Cornwall into the sea. The hope is flying right through the heart of heavy weather will help forecasters get better at telling us if we're in for scattered showers or catastrophic floods.
And Tom Clarke joins me now. So, Tom, just to ask a rather obvious question, why do you have to get inside a cloud to predict the weather?
Well, I don't think it's that obvious, actually. It's because the difference between whether it's just heavy weather or a full-on storm is dictated largely by how much energy, heat, is trapped within the clouds. Forecasters on the ground have got some excellent computer models, some pretty sophisticated radars and satellites, and they can help inform them. They can take some educated guesses about how much of that energy there is. But to really get a handle on it, you need to get up there to measure some very fine, detailed things. Really. You saw that shot of the individual snowflakes they're looking at. That's because when water freezes, it's being lifted up by warm air in a brewing storm, it freezes, but that releases energy. How much energy is being released? Where is it being released? How does that speed up or slow down the potential within those clouds to brew up even further stormy weather that leads to these high winds or heavy downpours that lead to local flash flooding? Right now, forecasters can't see that detail from the ground. What they want to do, go up there, see it in situ, and then model it with radars, then feed it into their computer models, such that hopefully in future they'll be able to better forecast more accurately where that really bad weather, that heavy rain might fall.
Tom, thanks very much. Krish.
After the break, he created the hairstyles that defined the 60s. But Vidal Sassoon, who's died at 84, had a background in Jewish activism that was rarely discussed.